Hello, in this lecture we will discuss about what is openrball, otherwise it is also known as opensphere or it is also known as openball. Then some examples of this openrball. Okay, so first let me look what is openrball. So for that I am considering a metric space XD metric space and an open ball with center x0 and radius be a positive real number. Okay, that is r greater than 0. So in this I am considering an x0. So this x0 element of capital X. I am considering an x0 here and I am considering a radius r. Then I am considering an open ball like this with center x0 and radius r. Let r be here. Okay. So then how we can define this open ball? Open ball with center x0 and radius small r is the set of all x. Set of all x element of capital X, but it needs to satisfy one condition. That means the distance between x0 and that x always be less than r. So we can consider this. This is that set. We cannot consider this because if we take a point here, then the distance between this x0 and x will be greater than r. Okay. So this is what we call open ball. Then I am in notation we can write dr of x0, radius r, x0 center, equal to set of all x element of capital X such that it needs to satisfy some condition, that is d of x0 x less than r. Okay, that is here mentioned. Okay, that is let XD be a metric space, let x0 element of capital X and r be any positive real number, then the open ball with center x0 and radius r is denoted by this notation. We can use this notation also. Most commonly we use this notation, and which is equal to this can be represented like this, that is set of all x element of x such that the distance between x0 and x must be less than r. Okay, so we can look one example, that is I am considering this is an example. Let x be a suppose let x be a non-empty set. It can be any. For example, let x can be set of all real numbers, anything. So x be a non-empty set. And I am defining d of xy. D of xy equal to set 1 if x not equal to y and 0 if x equal to y. So I think this is familiar because this metric is also known as, I think you are familiar with discrete metric. So d of xy, the distance function, is a discrete metric on capital X. That is not necessary. I just define only. I just mention only. Okay. So we want to find open ball of this discrete metric. So for that, I am considering. So by definition, we can write BR of x naught equal to set x element of x d of x naught x less than r. By definition we can write, but here in this case d of x naught x has value 1, 0, so on. So we can find this as a different cases. That is, if r equal to 1, if r is greater than 1, if r is less than 1, so the possible values of r are r equal to 1, r greater than 1 and r less than 1. So I am considering these three cases. If r equal to 1, that means BR of x naught equals set x element of capital X such that d of x naught x less than 1, then we have if it is less than 1, we can take d of x naught x equal to 0. Okay, x element of x. If d of x naught equal to 0 means what? The distance between x naught and x equal to 0. That is simply x naught. Set x naught. Okay, that is here. And if then let's look, if r is less than 1, then BR of x naught equal to set x element of capital X such that d of x naught x less than 1. If r is less than 1, that means 0. Take 0. So here if we are considering r is less than 1, we can put here 1, not 0. So if d of x naught x is less than 1, then we have the value element of capital X d of x naught x equal to 0. That means the distance between x naught and x equal to 0 means it is simply x naught. Then if r is greater than 1, that means here it is greater than 1, what will happen? D of x naught x can be 0 and d of x naught x can be equal to 1. That is what the all set capital X. Okay, so these are the open balls